Okay. Now, I gave us this example just now because it was one that you already knew the answer to, so you could confirm that it worked, okay? But let's now imagine if, example 2, let's go to that ridiculous, situation before where I said, let's just put like a ridiculous power in here, okay? And we'll start it from scratch. You've got y equals, now let's make it 30, okay? This is clearly impractical to expand, okay? But I can approach this with the same tool that I used here. Okay? If I let u, and I'm going to stop saying u as a function of x because I wrote that to clarify to you what was going on. It's not just another variable. It's a function. But I don't need to write it any more than I need to write that y is a function of x. Let u equal that thing on the inside. Okay? In fact, colloquially, it's often called the inside function. Right? That's on the inside, and on the outside, it's getting raised to the power of 30. Let u equal that function. So now I can differentiate that inside function with respect to x, because that's the variable I'm talking about. It's still 8x just like it was before, because this inside function and that inside function I have not altered. Okay. But now, because of this substitution, I can say y is going to be that inside function raised to the power of 30. And this is trivially simple to differentiate, just like that one was, right? dy on du, because it's a different variable, is just bring the power down and reduce the power by 1. That's it. That's all you need to do. And now comes in chain rule. I want to string these two derivatives, this guy and this guy. I want to chain them together to produce the actual derivative that I want, because these are just means to an end, right? dy on dx, I'm going to pull out this line again because we're just starting it, is dy on du times du on dx. Okay? Now, I'm just going to say quickly a bit of a note. I write this over and over again, even though it seems like it's going to be the same every time. As we will see, as we go further and further into calculus, and you remember I alluded to before, if you have something like the volume of a cylinder, okay, it's got its radius and it's got its height. You're going to be learning to differentiate with respect to different things and combining them in different ways. These letters up here, they are going to change. Their orders are going to change, their places are going to change. So I like getting into the habit of not skipping this step, so I know exactly what variables I'm dealing with. Okay? It seems trivial at the moment because what other variables are there, but you will soon learn there will be more. Okay, I'm going to pull my results in. Okay, I'm going to write this line, 30. I'm not going to write u because I know what u is actually equal to, because I introduced the substitution myself. 4x squared plus 1, 29. And then I've got my du on dx hanging on the end. 8 by 30. Done. As easy as tying your shoelaces. Okay. Now, a few things to note. This process, it's going to take a while to get familiar with it because it's kind of like your brain is expanding, you're learning all these extra repertoires, sort of extra skills in your repertoire. And so I really highly recommend that you do these steps to clarify where all of this business comes from. Okay? But as you proceed through, I mean, if I were doing this question and I weren't teaching it to you, from this line, from that line right there, the question, I would jump in right there. Okay? And the reason why is because once you become familiar, you see, this is clearly a function of a function. So number one, I've identified what it is, so I know what rule I want to apply through, established it, so now I can just use it. Okay? And then I see, you remember how I said there's inside and outside, right? That's a colloquial way of saying it. I just need to differentiate the inside, there it is, and then I just need to differentiate the outside. Do the inside, do the outside. If you don't like that kind of thing, it's multiplication, so you can just as easily do the outside and the inside. The order doesn't matter here, okay? But the key is you need to do both, right? The easiest thing is just to forget to do one of them, okay? And there it is. There's one, and there's the other. I go directly to this line, okay? And then you just put it together just to simplify it algebraically. That's all there is to it, okay? Now I want to emphasize, okay? I've gotten to this point after years, right? So this is why I'm putting it on the board. I highly recommend all of these steps, particularly like a lot of it is the first time you've met it, okay? So make really clear what you're doing. You're doing a substitution, okay? Later on, like I said, when we have different variables actually flying around, even the very best of you who are really, really, really confident, even me, who I could go to this line straight away, I'm actually going to say, I know what my substitution is. I'm going to differentiate it on its own. And then I'll have this. You're going to have so many functions flying around, in the same question, you really can't afford to just confuse yourself, right? So I won't always go directly to this line. But if this is the question, you will get to a point where you're comfortable enough, you can just jump straight in. Questions? Yeah.
Is this still like gradients?
Yes, it is. So, by the way, let's just think for a second. This function, what does that function look like? I have no idea. Okay, let's see. I think it's going to look something like, it's plus 1. I guess it would look like this. That's a bit lame, but anyway. I know because it's going to be plus 1, and then it's just going to be really, really steep because of this. Okay. Yes, it's going to be.
Wait, isn't that plus 1? Doesn't that shift it to the?
It shifts it up by 1.
But
So you think about this component, which is shifted up by 1, and then when you raise it to these powers, 1 has that curious thing that, like 0, no matter what power you raise 1 to, it will still be 1. So that was just by coincidence, okay? But then it's just really, really steep. That's all this does. Just make it really, really steep.
Yeah, it looks inside the bracket.
Yeah. Yeah, that's true. But if you rewrite it, if we were to do it, and you can see it in this line, if I were to go ahead and expand, can you see this one, which is the same as this one, really? It's always going to expand out to 1, no matter how big.
Yeah.
It's really actually modifying this guy. Do you see that? Like, it's not obvious, but it's really y minus 1. It has actually less to do with the x than it has to do with the y. Okay. So that would be the shape. Now, what is this thing? This is going to be another awful long polynomial. Without doing any expansion, you know what its degree is actually going to be, don't you?
31.
What was the degree of this one?
Oh, damn it.
What's the degree of this one? It's 4. It's 4 because it comes from 2 to the 2. If this was 2 and this was a 3,
59.
it'd be 6. That's right, because when you have a power of a power, just like a function of a function, you multiply those powers together. So this is going to be
59.
to the power of,
59.
yep, 59. You get 58 from here, and then you get the 59th from there, right? Which makes sense because this one is to the power of 60, right? Every time you differentiate, because of the whole way that differentiation works, you're losing a power. You lose a power, it decomposes down that way. Just like the derivative of x cubed goes to x squared, right? And the derivative of x squared goes down to a linear function and so on.